You'll stop drooling eventually. Okay, so yeah. So today we're going to talk about shut up. It's a word.
Yeah, the underminer from the Incredibles.
Cool. Do you know what undermine means?
What?
Well, what do you think undermine means?
Undermine somebody.
To mine under?
Yeah, it's like to basically sabotage someone, right?
Yeah.
Well, that's actually what undermining means. It means you go to the castle and you dig a tunnel under the castle so the walls fall in. That's undermining. Like, hey, you undermined us. The castle walls fell in.
That's why you call the underminer.
Yeah.
Is
It's
there a
John
way to
Ratzenberger.
call
I'm the
someone a
underminer. I'm sorry, what?
Can you call someone a moat?
Maybe. Okay, anyway, so today we're going to talk about why it is on the periodic table that those masses are not whole numbers. So if you remember before, we talked about how all elements have a certain number of isotopes.
Correct.
And there you are. Yeah, so anyway, moving on. So if you look at the periodic table, you're going to see the same thing. You're going to see the atomic number on top. And the atomic number is the number of what's? Protons. The atomic number is the number of protons. So all oxygens have 8 protons. Okay, all of them. 8. But not all oxygens have the same number of neutrons. Some have 6, some have 7, some have 8, some have 9, some have 10. And those give us our isotopes. And by the way, the atomic symbol, the reason that it doesn't always match is sometimes we don't use the Latin and Greek words anymore. Like K is potassium, we don't use calcium anymore. And F is iron, we don't use ferrous anymore. So if you're like, how come it doesn't match? Well, the good news is it matches more in English than any other language. But yeah, sometimes it just doesn't match. So we don't show the atomic number, or the atomic mass. We don't show the atomic mass. What we do show is something called the molar mass. And the molar mass is how much of a material you have in a certain number of atoms that we're going to be talking about on Thursday. A number called the mole. Okay? And to get a molar mass, we use a weighted average of all the isotopes. Now, you've used weighted averages before.
Correct.
Where in your world do you use a weighted average?
Grades.
Your grades, exactly. So next December, when you ask your history teacher what you need to get on the semester exam to get an A, and your history teacher is going to be like, I don't know, I can't do math. You're like, well, let me walk you through it. So you have a quarter one, and your quarter one is worth 40% of your grade. Looking familiar?
Yes.
And then you have a quarter two, and your quarter two is worth 40% of your grade. And then in the second week of December, you're going to take a semester exam, and it's going to be worth 20%. Now, if this was a simple average, you'd add all three and divide by 3, right? But that would mean each of these would be worth 33%. So we don't use a simple average, we use a weighted average. And good news for the history teacher, the computer does it for him. But what we're going to do is we're going to say, all right, I'm going to take the weight of quarter one at 0.40, and I'm going to multiply it by what I got in quarter one. What did I get in quarter one?
92.
92, all right, sounds good. And then I'm going to take the weight of quarter two, multiply it by 0.4. What did I get in quarter two?
86.
87, okay.
Yay, I said 87.
Oh, I said 87.
And then on the semester exams were 20%, so we're going to put 0.02. What did I get in the semester exam?
67.
67, okay. 67. So if you do not have a calculator yet, you're going to need one. Multiply each of these pieces and then add them together.
Okay.
Plug.
Okay, I got
Take
that.
your pick.
That's cool.
Hey. Why did these dudes get
I like the
the
one.
napkin?
I have more coming.
So what's the difference between these ones and those ones?
These are, there's so many differences. These are only like 3 years old, and they run a fork of Python, which is open source. So you could technically create programs for these, upload them, and then run them on this.
So that's how you play
These
games.
are ridiculously expensive TI calculators that are not open source. They are almost 20 years old, and that. They're really, really expensive, and they use proprietary software. So these are better and faster than these guys. But what these guys do have is they used to have a modem where you could connect them together, and then you could be like, here's my answers. And the other somebody else would be like, hey, thanks for the answers.
You get an
Hey, my mom
85.
talks about those. Low key.
The site, that's CXs. Yeah, the only reason I got these is because they got sent to the math department. Math department did not know what to do with them, so they gave them to me. All right. And then I was introduced to these guys, the number calculators. These are amazing. So I've been trying to get more and more of these every year. I usually get 2 or 3 on a grant. Okay, so you got all those pieces, and when you add all those pieces together, you do not divide by 3. The dividing by 3 happens in the percentage already. So it's like, if it was divided by 3, we had 0.33 times that, 0.33 times that, 0.33. So the weights take care of the dividing. But just like any average, it should fall between the lowest value and the highest value.
I got 85.
I got
85?
Like on the dot.
You got 85 on the dot?
Yeah.
All right, sounds good to me. So 85.0. Again, you just like any average, it should fall between the smallest number and the largest number. But you never divide by 3 because the percentages do that for you. They don't like, it's not 1/3, 1/3, 1/3. It's 4/10, 4/10, and 2/10. Okay, if this is clear to you, give me a thumbs up. If any part of this needs to be repeated, wave your hand around. Okay, so go ahead.
Basically, you added 0.40 plus 992.
Times.
Oh, you
That's the
multi-
dot.
Yeah.
Okay, and then you add all those together and you get, okay.
Exactly right.
I got
I'm
it.
taking my raw score and giving it a weight. Taking my raw score and giving it a weight. Taking my raw score and giving it a weight. And then adding those 3 pieces together.
Okay.
Other questions?
Nope.
Moving on. So with isotopes, the number we give to how much of it is on this planet is called natural abundance. And this number is constantly being repeated or constantly being reinvestigated for pretty much every element. In fact, that was one of the test questions you had last, or one of the worksheet questions you had last unit. Why does this isotope constantly have to be changed and changed and changed? Why do the natural abundances, which like this isotope is 30%, this isotope is 6%, this isotope is 48%. Why does that number have to be constantly updated?
Sort of not accurate because nuclear decay is always happening.
Exactly. Because nuclear decay is always happening, the percentages of various isotopes is constantly changing. So I guess if you want job security, that's what you want to investigate. Okay, moving on. Okay, so once again, there are 4 isotopes of carbon, 11, 12, 13, and 14. They all have the same number of whats?
Proton.
Protons. But they have different numbers of neutrons, giving them different weights. So this is how you do the math. You say, all right, I get that isotope 1. I'm going to take its relative abundance, give it to me in a percentage, and I'm going to multiply it by its mass, which will be given to me. 11, 12, 13, 14. Isotope 2, its relative abundance, multiplied by its mass. And isotope 3, its relative abundance. And you just keep doing that until you run out of isotopes. Yeah. So AMU means atomic mass units, but we don't use that. We use a number called gram per mole. So when you have found your average atomic mass, we basically rename that gram per mole or the molar mass. It is the mass of 1 mole of a stuff. And we're going to talk more about that on Thursday. Just a little preview, the molar mass is how much of a material you have in a certain number of grams that matches the periodic table. So I have 12 grams of carbon. There's 12 on the periodic table. That is 1 mole unit. We'll talk more about that on Thursday. All right, if you're ready to do some more practice, give me a thumbs up. If you have any questions, wave your hand around. Yes.
So how do you find the abundance? Will it just tell you, or?
Some old dude found it and wrote it in a book.
Nice.
And then you go back and say, well, in 1965 it was that. We need to figure out what it is now. So we just look it up.
Okay.
Yeah, these are constantly being revised. And yeah, it was revised a lot back in the 40s and 50s when we couldn't stop dropping bombs in the Nevada desert. But now it's just revised a little bit. So we move forward?
Mhm.
We move forward. Okay, practice for you. Elements of Wagnerium. So the Wagnerium has 3 isotopes. Wagnerium 18 is 25% abundant. Wagnerium 19 is 60% abundant. And Wagnerium 20 is 15% abundant. What I would like you to do is use the system we just learned to figure out what is the average atomic mass of naturally occurring Wagnerium.
So wait, would we multiply by 25 or 0.25?
0.25.
Okay.
Yes. We're going to convert our percentages into decimal form. Again, there's no dividing by 3s.
That's what I got.
Yeah, so once you get a number, lean over, show your neighbor, see if you and your neighbor agree on whatever the number is.
Hold on.
And again, as a little bit of a check, any average, including weighted averages, will always fall between the smallest number and the biggest number.
So what'd you get?
18.9
18.9.
grams per mole?
Yep.
All right. If you got this number and you understand why you got it, give me a thumbs up. If you didn't get this number or don't understand why you didn't get it, wave your hand around. Okay. One more. Actually, there's 2 more. The next one is this. The element gallium, there are 4 isotopes that are naturally occurring. 34 AMU gallium is 9% abundant. 35 AMU is 25%. 36 AMU is 59%. And 37 AMU is 7%. Before you calculate it, I have a question for you. Is 7% converted to a decimal 0.70 or 0.07? It's that one. We're still moving in 2 decimals. So be careful, because sometimes your number will be like wonky. It'll be like 0.2%. You're like, oh, it's already a decimal. Nope. If you get that, you still got to move the decimal 2 places. Remember this?
Yes.
Okay, cool. So go ahead and determine the average atomic mass of gallium. And see if Keegan's right. He did have a question, so.
No, he was just born like that.
No, bad one.
He probably doesn't even know what we're talking about right now.
A little jealous. Wow. Okay, I'll turn the lights on. Sun-
No,
no, okay.
It's good.
The sun is going away.
Did you
It's coming
get
back.
it? Did you
It's
get
coming
Hold on.
back.
Did anyone get it? Because I got
35 point.
Yeah, that's what
Again, as a little bit of a check, your number should fall between 34 and 37.
I got
I got 35.64.
35.6 grams per mole?
Yeah.
All right.
Wait.
If you're happy with this and comfortable with what's going on, give me a thumbs up.
I'm
Any
not
questions? Wave your hand around.
Oh, wait, no.
No.
One more piece of skill before we move on to you working on your own, and that is mass spectrums. So this is kind of neat. This is the mass spectrum of germanium, and I've removed the little like 0.01s, or removed the bits and pieces to give you reasonably whole numbers. But this is the mass spectrum of germanium, and germanium 70 is at 20%. Germanium 72 is 30%, 73 is 10%, and germanium 74 is 40%. If you wouldn't mind, go ahead and figure out what the average atomic mass is of germanium.
How are you going so
Can you
fast?
just shush before we go?
Gotta give everybody else a chance to catch up.
Yeah.
I know, I was that kid too. Look how smart I am.
Alright, now you just shove it in our kids, man. There's no need for that.
It's okay, Keegan's a calculator warrior. He's not actually writing notes.
Oh, buddy. Let him not do that though. Stop it, bro.
Yeah, there will be, there will be one of these on your unit test. So you just need to be able to read the graph. So, and it's not gonna be like this is 28.8. It's gonna be like right on 30, right on 40, right on 20, right on 10.
Thank God.
Yeah. I feel like 81.2. I thought it was 81. It's 81.3. Okay. Did you get a number somewhere between 70 and 74?
Correct.
Yes.
72.5.
72 and a half?
Yep.
Excellent. Okay. So that's it. Any questions? No.
No sir.
All right. Then you can use the rest of the time to work on your skills.
I'm a genius.
Wait, okay, that was fine. I actually got this on wrong.
It's the first thing we've done that's easy.
No.
Right.
Well,
Yeah.
well, the video started it, but.
You're, hey,
Yeah, for you. That is about you, Keegan.